So a projectile shot at 32.1 meters per second into the air at 52.6 degrees above the horizon was the range, time, and peak height. As a reminder, range is how far it's going to go, or d of x. Time, how long it takes, and peak height is how high in the air it goes, which would be d of y. So the first step in solving angled projectiles is to sketch and solve for the vector components. So our projectile is shot in the air, so it has an initial velocity of 32.1. That comes from the problem. And it's shot at 52.6 degrees above the horizon. So it looks like this. But that is not all that I'm asking for when I say sketch it. So let's look at the path of this projectile. It's going to go up, super tall. It's going to come down. This would be my max height. This would be my dy. This would be how far it goes. That is my range, which we call d of x, dx. Now, my initial velocity is 32.1 meters per second, but that velocity has both x components, which is that side, and y components, which are up and down. We don't want those together. We want to separate those out. So we're going to show our vectors. So my x vector would be like this. And my y vector would be like that. So to solve those, I'm going to use that trig that we learned on Friday. Remember, r is my resultant. In this case, if this was a triangle, r would be this. It's my hypotenuse. So I would go 32.1 sine of 52.6. That's my y. And 32.1 cosine 52.6. That'd be for my x. Make sure your calculator's in degree mode. Zoom out a little bit. Turn on my calculator. I'm going to hit mode right here. And make sure that that degree is flashing. Hit enter. Second quit. And I'm ready to solve those. So my y component, my initial velocity in the y direction is 25.5 meters per second. My initial velocity in the x direction, which is side to side, is going to be 19.5 meters per second, because I'm going to round that off. This has 3 sig figs, this has 3 sig figs, so we're just going to keep it at 3 sig figs if we can. Alright, so now I have my initial velocities in both the x and the y direction, but I'm nowhere near being done on this. 2 says solve for the time up. Remember, at the top of the trajectory, so as high as it can go, what is my velocity here in the y direction, just for an instant. When it stops going up, but before it starts going down, what is it? 0. So right here, I can use that final velocity because this is the distance I'm looking for. All right, so I'm going to use my formula, the same one I've been using for the last 2 months. A equals VF minus VI over time. I'm just making sure that I use my direction of Y. I'm calling this time up because it's the time it takes to get to the very top. My acceleration due to gravity is -10. My final at the very top is 0. My initial we found to be 25.5. And my time up, I don't know. I want to get my time off the bottom, off that denominator, so you can either cross multiply and divide, or for me, I'm just going to multiply both sides by time up. So I get -10 time up is equal to -25.5. I'm going to divide both sides by -10. My pen starts to work. Oh, I'm trying to write an S and I forgot how. Okay. And my time up should be 2.55 seconds. Everyone with me so far? Okay. Now, my time up stops right here. To find my total time, I need to multiply because this amount of time right here is going to equal this amount of time. So to find my total time, I'm going to do 2 times my time up. So 2 times 2.55 is going to be 5.1 seconds. That means it traveled as far as it could in 5.1 seconds before it hit the ground.
Wait, so the total time that's including it going up and down?
Up and down. Any other questions before we move forward? Sorry. All right. Now, the next 2 steps you can do in either order. I've just been using Y, so I'm going to stick with Y and finish that off. I want to solve for my peak heights. To do that, I'm going to use the same formula that's been on the board now for, I don't know, over a month. My squared fell off right there, so don't forget to add that back on. A equals VF squared minus VI squared over 2D. Now I'm just making sure to stay in my one direction. I'm still using the initial velocity that we found. I want to get 2D off the bottom because nobody likes fractions. I'm going to multiply both sides by 2D. And I'm going to get -20D equals -25.5 squared. You cannot square a negative. But remember, sorry, hold on. I got the article. I'm so sorry, that was on me. remember, is plus or minus the square root of. So we can kind of set that negative to the side for a second. So 25.5 squared is going to give you 650.25. So we're at negative 20d equals negative 650.25. So 650 divided by, or 650.25 divided by 20 gives you a distance of 32.5 meters. How are we feeling on this? It's basically the same stuff we've been doing. I told you next unit, whole brand new bag. This unit's just, we're building and building and building. So after next week, I can actually erase these formulas off the board. I'm pretty excited. All right, the second part, 4, says solve for the range. I cannot use this same formula in the x direction because I do not know what my final velocity is in the x direction. I could solve for it, but it didn't ask me for that, so why would I want to? So I can use my distance formula. Distance equals vi times time plus 1/2 at squared. What is the acceleration of a projectile in the x direction? When we're filling in this t-chart, right there goes what? 0. One-half times 0 times time squared is going to be 0. So I can delete it. I don't have to worry about it. It's gone. Which means my range is going to be equal to my initial velocity in the x direction times the time spent. So that my d of x is going to be, what was it, 19.5 times my total time of 5.1, because it took the entire time to get there. .5 meters.